Good morning, everyone. I'm going to be talking today about different techniques to help us capture packets. How do we actually get the packets off the network into the capture unit? There are some tried and trusted methods which we'll cover in the presentation, but of course things are becoming more challenging with issues around things like blade servers, virtualization, etc. So we're going to cover some of those issues as well. There are a number of ways we can do this, and I've grouped the techniques together into areas that cover directly capturing off of the end host. Slightly controversial, but we'll discuss that. Capturing based on the capabilities of the switches in the network, using some sort of purpose-built device such as a tap. How do we do it in the virtual environment? So I've grouped those together. So we'll cover each of those areas, and what I'll do is I'll stop periodically and invite questions from you. So let's start with some simple techniques. We can obviously capture on the PC, something we probably have all done at some point or other. Fire up Wireshark, get it running, start it capturing packets. The interesting thing about Wireshark when it's running is that when you start Wireshark, you get the Wireshark executable, but then when you start a capture, you actually also get another executable called dumpcap. And as you probably know, you can run dumpcap from the command line. So we can think of Wireshark as being a graphical user interface to dumpcap, if you like, when it's in capture mode. Obviously, when you're analyzing, it does so much more. The important thing here is that Wireshark and T-Shark have to create structures as they're capturing. So they interpret the data as it's being captured, and so they gradually consume more memory. So if you're doing long-term captures, and I mean in terms of days or weeks or even months, as sometimes we've had to do it, Wireshark and T-Shark are not the thing to use. What you want to use is dumpcap and just save directly to file. So that's a consideration that we need to make. Now, the other issue I should point out when we're capturing directly on the PC is sometimes we get traces, hopefully you can see this, where we get very large packet sizes. And if you were in my session yesterday, and I know some of you were, you'll know that we talked about TCP Segmentation Offload. Just to add my caveat from yesterday, I've taken a certain amount of poetic license with the way I've drawn this diagram, but this is probably the best thing I could come up with to describe this. But anyway, if we're capturing on the PC, we'll be capturing about this point here, and if we're capturing on the outside, we'll be capturing maybe with a tap or with a span on the outside interface into the network. Now, the thing, of course, to note is that we might have a packet that we send here which has got 5K of payload. I've seen 64K packets being sent across that interface there. So in my trace that's taken on my PC, I will see very large frame sizes. But when they hit the outside world, they just get repackaged and resegmented, and they get sent to the PC over here or server in standard 1518 byte frames or 1460 payload, or whichever way you want to look at it. Interestingly, when data comes back in the opposite direction, it does not get reassembled back up unless you're using a feature called large receive offload. All the traces I've ever seen involving TCP segmentation offload, I've never seen LRO in use. I'm not saying that it's not out there, but to point out that I haven't ever seen it, and I'm not sure how common it is. Okay, so that's a consideration when we're capturing on the PC. So the advantages of capturing on the PC, it's pretty easy to do it. It obviously doesn't disrupt any services other than the person who's using the PC. We can capture wireless traffic. But this one is a really good one. We can capture inside the tunnel of a VPN. Now that's something we can't do on the outside. of the PC. A quick note on the tunnel, on VPN tunnels. You'll find that Wireshark will capture from some tunnel types. So we use WatchGuard, and it's an open VPN client, I think, basically. And Wireshark seems to be able to handle that quite well. Before we switched to using the WatchGuard solution, we used to use Microsoft's native VPN support, and Wireshark couldn't capture inside the tunnel on Microsoft native VPN. What we found was Netmon could, or Microsoft Message Analyzer, Netmon, whatever you want to call it, that would capture within the tunnel. So if you get stuck and you need to try something different, I'd try that. Of course, you can then pull the packets into Wireshark and analyze them in the normal way. Some considerations when you're capturing on the client. TSO can confuse things. Discontention can cause loss of packets. And for that reason, and the fact that you may end up causing a performance hit on the PC, the main thing is don't save the data to the C drive if you're in a sensitive production environment. The C drive obviously is used for page file system, XEs, DLLs, memory map files. If you start hitting the C drive quite hard with trace data like this, then the actual execution of programs is going to start to suffer. We use USB drives a lot, just a standard type of plug-in USB drive, and they're very successful. But obviously you may have security, you know, your USB ports may be locked down, there may be some security issues there, so you're going to have to plan around that. Sure.
You're talking about using dump cap at this moment?
If you're just doing a capture, say you want to just test something, or you want to do a quick capture of a problem that's recreatable, by all means use Wireshark. If you're going to run dump cap, say you've got an intermittent problem that only happens once every couple of days, then what you want to do is run dump cap with writing, say, 200 megabyte files, a ring buffer of, say, 8,000 files, so that will give you quite a long time span, and just leave it running. But you want to use dump cap in that case. So Wireshark if you're just doing something quick, dump cap if you're doing something a bit more serious. Okay. Okay. Jump to my very next bullet. Okay, so yeah, dump cap for long-term captures. That's capturing on the PC. Now let's talk about capturing on the server. It's much the same. We run the executable. This time I would advise you definitely to use dump cap and not to use Wireshark, the full Wireshark suite. One of the advantages of doing this is that you not only see the traffic that you expect to see, you also see the traffic that you didn't even know existed, which is a great advantage of taking this type of approach. This is becoming more popular. There was a time when people would just totally dismiss the idea of running captures on servers, but there are becoming so many issues about capturing from the network infrastructure, and particularly in virtualized environments. This is becoming a much more acceptable way of doing things. I'm surprised. I really am, but that's what I've found. I was really surprised when I went to one of the UK major clearing banks and we wanted to do some captures in that environment, and they said, why don't we just run Wireshark on the server? I was shocked. But there you go. I guess it's a testimony to the stability of Wireshark and the reputation it has to some extent. So advantages of running it on the server: easy to achieve, minimal disruption, although you're unlikely to be able to do it without some form of change request and probably some form of testing to make sure it doesn't cause a problem. Even if you know it doesn't, there are people who will want to be convinced of that fact. All the client traffic is visible from all the clients of that server, and all interactions with other services are visible. It's also useful because you can capture if you've got blades in an enclosure, or you've got a VM running connected to a vSwitch, not only do we see the north-south traffic going from the enclosure out to the rest of the world, we also see the stuff going between the blades or between the VMs. I'll cover this in more detail later on. Considerations. So the first one is the one that we've talked about. TCP offload can be confusing. The other thing is that when you're running on a server, obviously the volumes are much higher. So the volume of data is higher. And that means there's an even greater compelling argument not to go and save on the operating system disk or any other sensitive volumes such as database log files, etc. Of course, many times what this will involve is actually it could be that you end up saving out to your storage area network. And again, you need to plan that carefully, make sure that you're sending it to LUNs or areas of the storage area network that will not cause problems elsewhere. No, don't capture your file system traffic, that's true. As I sort of alluded to earlier, I would definitely use dump cap in this environment. I wouldn't even consider using Wireshark or T-Shark. We're going to look at teaming and the issues around teaming later, but that can trip you up quite seriously. So you need to consider the fact that there may be teaming of network adapters. The other thing is that you can't trace between processes running in the same Windows operating system. You certainly can't do it with Wireshark, but we're going to take a look at how you can do it. You can do it with Wireshark on Linux, and you can use TCP dump on Linux. Say you had a web server and a database running on under the same operating system. Obviously, we'd probably like to see the traffic flowing between those two programs. We can do it on Linux or any of the *nix versions quite easily because there's a standard loopback adapter. But although there's a sort of loopback adapter on Windows, you can't trace anything that makes any sense or is useful. Does anybody know any difference to that? Just in case because we've tried it on loads of occasions and we've not found a way of doing it. We can trace within the Linux environment in this way. The source and destination IP addresses will always be the loopback adapter address, and so that throws the emphasis on making sure if you want to know which direction the packets are going in, what you really want to look at is the port numbers, either TCP or UDP port numbers, and that's how you'll determine the direction of the packets. So there is this program, I'm not sure how well maintained it is, but there's this thing called RawCap, and RawCap does enable you to capture between two processes running on one operating system. So you can see the TCP IP flows between the application server and the database server. There are a few issues. It produces PCAP files, which is good, but it's IPv4 only. And often Windows now installs default with IPv6, and I think often it's IPv6 that's being used between the two processes. So one of the things we have to consider is, do we have to use IPv6 and can we switch it off and all those types of things? This is a tricky area, though, I must admit, tracing this type of traffic. The other potential way of doing this is using Microsoft's Process Monitor, Procmon, but Procmon doesn't show you data content, so all you'll see is the very basic headers, addresses, port numbers, message lengths, I think is about it. It only works on 2008 R2 upwards, which is slightly bizarre as it only works with v4, but that's how it works. Any questions so far? Okay. The classic controversial span session, monitor session, mirror session, depends on which make of switch you've got, but probably any enterprise class switch that you're ever likely to come across has this type of capability. And the capability is to reflect the traffic that's going in and out of, say, a port into some sort of monitor port, a destination port, and thereby capture that traffic. So that's a fairly typical topology. In Cisco, you enter a command monitor session, you do it twice. You do it once for the source, once for the destination, and in Juniper you can do a similar command. Obviously there are others for the other switch manufacturers. I haven't attempted to research them all, but I'm sure you'll be able to find this capability in most switches. So rather than do an end host port, you could do, say, an uplink, and so you will capture all of the traffic going north-south. So we'll see all the PC to server traffic. We won't see any server to server traffic. We'll see all the phones to IP telephony system traffic, but we won't see any stuff that's flowing between the IP telephony components. That's one possible configuration. And here's the concept of north, south, east, west. Instead of monitoring a whole uplink, what we can do is we can monitor a VLAN. So now we're perhaps monitoring the VLAN that has all of the servers within it. Now we can see PC to any server. We can see server to server traffic, but basically we can't see anything to do with IP telephony. You can go on to monitor multiple VLANs and multiple ports and all those sorts of things. Those are all possibilities, certainly within the Cisco world, but there are some issues that may arise, and we'll look at those issues in a second. One word of warning here is that certainly when you set up a monitor session, sometimes you may capture the traffic twice, because you capture the traffic as it comes into or goes out of the VLAN. And so you may see, for example, a packet coming in here and then going out here. You will see that packet duplicated in the monitor session. So just be aware that you may get duplicate packets. You may have to dedupe it. There's a Wireshark facility to dedupe packets, or an edit cap facility, I think it is. So you can actually dedupe some of these trace files. So I thought I'd add in some of the pitfalls and some of the holes we've fallen down. The first one is this concept of asymmetric routing. We might have a setup like this, and we might establish that the route from the servers out to the wide area network is via this primary router over here, and we've got a secondary over there. So active, standby, primary, secondary, call it what you like, using things like HSRP in Cisco and VRRP in other technologies. So in this situation, what we might do is set up a capture for this link here. We'll see the traffic going outbound through the primary interface or the primary router. But unfortunately, what we find is that the traffic in the opposite direction is coming back through the other path that we're not monitoring. We've fallen down this hole several times. You'll get people who insist it's definitely going to go this route. The traffic in and out will definitely go this route. We've got, what's that thing called? Tracking. I can't think what it's called. Yeah, where it tracks which one's primary and which one's secondary, and propagates the correct routes into the WAN and all that stuff, and then you find you still miss it. Do yourself a favor, capture both. Preferably capture both on a capture unit with 2 ports, so that it's all on a common clock. To give you an idea of the practicalities of this, I outlined this yesterday, but mostly when we're doing these types of captures, we use Dell R320 or R420 1U servers. Servers is the preference for getting it installed into a data center. Obviously, if you try and install anything else, the data center manager is not too keen. And then we will have multiple interfaces on the back. The Dell comes with 2 onboard interfaces anyway. We use those for management. We'll shove an Intel Pro 1000 card in it, and then we'll stick one side of it into one monitor port and the other 3 port into the other monitor port, and we're capturing both sides on one unit. So that's how we do it, just to give you an idea. I'm not advertising Dell here. Other servers are available and they will work. Okay, so that's the first thing that might trip us up. Then we come on to the other favorite that often trips people up, is this whole concept of teaming. Typically what has happened to us in the past is we'll say to the server people, do you have teaming on the server? Yes, we do. We work out which ports it's connecting into. We say, what mode is the teaming working in? Oh, it's working in failover mode. It's not working in load balance mode. No, it's definitely working in failover mode. Then you trace what you think is the active side of the failover, only to find out it's working in load balance mode. And so you miss the traffic. So do yourself a favor again here. If you're going to do this, make sure you trace both interfaces. Now often, although this type of teaming is now very popular because of the standardization and all of the advantages you get using the teaming protocols, a very traditional way of doing it is to actually team and split the interfaces into 2 core switches or 2 top-of-rack switches to cover all sorts of failover eventualities. So again, preferably use a capture unit with 2 ports and capture both interfaces, no matter what they tell you about failover versus load balance. Advantages: easy to configure, low risk, it's non-invasive. I will come on to the whole, there's a bit of a Cisco Nexus controversy going on, which I'll come on to in a minute. But it's pretty low risk. You would want to make the change through change management. There is one slightly annoying thing, certainly with Cisco. If you define the commands and you get the ports round the wrong way, so you define the source as being your monitor port and the destination as being the port you're trying to monitor, you'll kill the port that you're trying to monitor. I can't for the life of me understand why Cisco haven't put a safety mechanism in there to stop you doing that. It would be so easy. Just make sure that you can only specify a destination that's currently down or something, you know, and then set the spam session up and bring it up. But no, you can't do that. So just a word of warning there, you can mess things up. You can have multiple sources into one destination port, but there are some issues around that, which I'll come on to in a second. You can do entire VLANs. You may see duplicate packets, so just be aware of that. Something I touched on yesterday, understanding whether you're seeing a duplicate packet due to something like this or you're seeing retransmissions. If you're seeing TCP retransmissions, the sequence number may be the same in each retransmitted packet, but the IP ID will be different. If you've seen the same packet, sequence number and IP ID will be the same. So that's just something you can check. I've heard all sorts of horror stories about this. I haven't had anybody prove to me any measurable impact on the performance of the switch or what it's doing. Certainly on Cisco, a lot of this stuff is done in ASICs, so it's purely an electronics thing. I'm not aware of any performance impact in doing this. Now, another gotcha, which I should tell you about, is let's say that we are monitoring a whole VLAN and we've got a PC here talking to a server there. We're monitoring the VLAN. We decide the only spare port we've got for this VLAN is on another switch. So we set up a monitor session over there for VLAN 130. That won't work. It's got to be on the same switch. So just be aware of that as well. If you haven't set your monitor session up correctly and you connect your capture unit or just connect a PC with Wireshark running, what will you see? If you just whack a PC into a port on a switch without any monitor session, you would see that PC, I guess, yeah. Yeah, broadcast and multicast. So if you ever set up a monitor session and all you're seeing is broadcast and multicast, then go back and check to see if the session's been set up correctly. Another word of warning, you've got a source port, perhaps it's a 1 gig source port, full duplex. In theory, that source port can be generating 2 gigabits per second total aggregated load. And then you're trying to feed it into a 1 gig monitor port. What you really need is 2 gig. So you may lose packets. And this is not the loss of packet that will be detected here, because of course your capture unit has never even seen it. So dump cap hasn't even seen the packet. These are packets that are being dropped actually on the switch. So be aware of that, and also the fact that certainly on Catalyst 6500 type switches, this can cause some queuing on the destination port, and so that messes with your timestamps. Whenever you use this type of technique, you may lose a few packets, but hopefully you get enough to do what you need to do. And when I say a few packets, you know, you could lose, say, 2% of packets and probably not be too bothered by it. You may occasionally see things where it says previous TCP segment missing, or whatever the wording is, but you'll be able to work out what's going on, and hopefully it won't be the precise packet that you actually need. So to explain, Advanced 7 goes into large organizations and tries to help them troubleshoot end-to-end problems. And we often try to do this quite quickly. And the idea of installing taps, you know, having a change cycle where we can disconnect servers and install taps, is just not practical. So in that situation, span is the only way we can really go.
Well, if the source port's only running at like 10% of its capacity,
yeah, sure.
Like, you don't have to worry.
No, absolutely. And you would hope that no source port is going to be running 100% full duplex. So yeah, the only time you sometimes see it is if they're running something like backups. You may see it peak. You may see it go above 1 gig in total. But yeah.
Question.
Yeah.
You may be able to tell the Wireshark if the host is running 100% capacity, 1 gig. Can you tell that to the Wireshark?
Yeah. Yeah, you could, couldn't you? Because you could do an IO stat graph or whatever in Wireshark, and you'd see 1 gig coming in. Well, you'd probably see slightly less, but you'd see about 1 gig, and so you'd know that it's running flat out of the destination port.
Doesn't it actually show drop packets here?
It does show drop packets, but that's more an issue about whether I can get them off the NIC through the kernel out into user land and then back out onto the disk. That's what it's recording. It's recording the loss of packets there. It doesn't record the loss of packets that are happening at the switch, because obviously it doesn't know what's happening at the switch. Yeah. Yeah, absolutely. Yeah. You could report it with NetFlow. Yeah, definitely. Okay. Now this is, I'm really going to take my life in my hands here, because this is a controversial subject that I've spent ages trying to get to the bottom of. I'm still not convinced I completely know it, but I'll tell you what I know so far. So Cisco Nexus switches are cut-through switches. Cut-through means the packet starts to arrive on the ingress port. The switch looks at the header information, at least Ethernet, probably further into the packet, makes a switching decision, and then starts to squirt the packet out of the egress port before it's come in the ingress port. So cut through, less latency, as opposed to store and forward, where we had to take the whole packet in, make a decision, then send it out. Okay, so we're trying to get down below the sort of, I don't know, nanosecond switching time or whatever we're trying to achieve here. So in theory, we could just do it with the destination MAC address, but the trouble is that the Nexus switch may have ACLs configured that are based on other properties within the packets, like I'm only going to allow certain IP ranges, IP address ranges, or TCP port numbers and things like that. And so in that case, we have to see more of the packet than just the destination MAC address. Whereas with the Catalyst switches, there was an output queue, and if you couldn't send the stuff out of the output queue, it may get dropped. And one of the output queues obviously could have been a monitor port, and so we might drop packets. But because of the cut-through nature of the switch, what we actually have on a Nexus switch is we have this virtual output queue. So every ingress port has a virtual output queue for every destination, possible destination for the packet. So then what happens is if the outgoing port is quite busy with other traffic, then stuff starts to build on this virtual output queue. So that's all well and good. And okay, so eventually and you can see some attractions there, because as this queue builds, we could actually start to throttle the traffic coming in, because we could start to send things like Ethernet pause frames and try and quench the flow of data into the switch, into that port, which is all well and good if you're doing something like we're showing here. But if you're doing it with a monitor session, now we've got the issue where we've got a packet going out of the monitor source, and we have to copy that into the monitor destination. We've got a packet coming into the monitor source, so we've got to copy that into the monitor destination, and then we've got production traffic coming in trying to go out of that port, out of the monitor source port as well. And so that's why we get this back pressure effect, because if the traffic starts to effectively queue on the destination, it actually causes it to cause back pressure upstream. So that's my explanation. What's your one? Does anybody have something? Somebody got anything better than that? Yeah. Oh, yeah.
What happens when the Ethernet checksum isn't installed?
It passes it straight through, actually. But you can. So the question was, what happens in a? I take it you mean in a cut-through switch? What happens?
Yes.
Okay. What happens in a cut-through switch if the checksum doesn't match the content of the frame? Actually, what happens is the switch still doesn't take any action on it. It passes it through. But anyway, the main thing is it leaves it to the end destination to actually just throw the packet away. So a packet with a checksum issue could pass all the way through the switch network until it reaches its destination, and when it reaches its destination, that's when it gets thrown away. The idea is, I think, that checksum errors are not so common as they used to be, and so let's let someone else handle it, and let's just concentrate on switching as fast as we can. I think that's what this is all about. You're pushing my knowledge here because I'm not really a networking person. So anyway, so we get this queuing due to monitor destination port congestion. If you search high and low, and I don't want to read a read along here, but this is some of the words that you'll find in Cisco documentation. And I think the main thing I wanted to do is pick out this stuff in pink where it says impacting monitored production traffic, which is the more worrying thing. And there are ways to avoid it. And what you can do is you can use rate limiting to limit the amount of traffic that's being sent out of that port. Okay. So, considerations with span and monitor ports. We can overload the destination if we try and push 1 gigabit per second duplex into full duplex into a single 1 gig port. There's some back pressure issues on Cisco Nexus. Certain switches have a limited number of monitor sessions. Traditionally, on Cisco, it tended to be 2. On Juniper, I think it might be 1 on a lot of the models. And on HP, I think it's 1. And so, yeah, so there are some issues that you have to consider there. You've got to obviously have a spare port on the switch. That's usually not an issue until you go to some remote office where they've just been plugging more and more things into the switch, and there are no spare ports, which is something we came across just last week. So that can be a bit of an issue. This whole area, obviously, it goes without saying, there's a tremendous amount of variation in the finer detail of doing this, and you really need to read the documentation to set this up correctly. But certainly for the, I'm sorry to keep on about Cisco, but the majority of our customers run Cisco, and so it's what I know the best. But the Cisco documentation is very good on this. There's a whole sort of web page about setting up span and monitor sessions. So Cisco also have another way of doing this on Catalyst, the Catalyst 6500 range or whatever, Catalyst switches. It was something called virtual VLAN ACLs, VACLs. And on Nexus, it's simply termed as ACL, Access Control List. Access Control List enables us to specify some criteria. We match on that criteria, and then we can take some action. And with VACLs or with ACL, the action you can take is you can choose to forward a copy of the packet to another port. This enables you to actually create endless number of monitor sessions in theory, and also enables you to select some of the data. So if, for example, you've got a 10 gig source port and you're trying to output that into a 1 gig monitor destination port to go into your analyzer, then you've got the ability to actually effectively filter the traffic and say, actually, I only want to be presented with traffic between these two IP addresses or some such thing. So that enables us to send filtered traffic, say for a server, out into a capture unit. Advantages of this: VACLs capture on Catalyst, ACLs on Nexus. It's more or less the same type of capability as span and monitor and mirror type sessions, but you can have this wide range of criteria to decide what you actually want to capture, and you can have more sessions. I think I saw on Nexus 7000 you can have 64, effectively 64 monitor sessions. Monitor sessions used to be totally the resource that the network engineer would use to actually capture packets. But now, of course, everybody wants a monitor session. Intrusion protection and detection systems, certain sorts of voice recording systems. There's a whole bunch. Everybody seems to want a monitor session. It's not uncommon for us to go somewhere and find that there are no free monitor sessions available. And I guess the question is this the way forward with Cisco, particularly as we're now facing the issue where we've got 10 gig, 40 gig, 100 gig. How are we going to actually capture that stuff? Aside from the fact that you need the hardware to do it, we don't have the disk bandwidth to actually capture traffic at those sorts of rates. So the use of some sort of selective capture is quite attractive. Considerations, same as mirror ports. These are complicated to configure, and so there's a greater possibility of impact in production if you make a mistake, that's for sure. You may not capture the traffic you expected if you miscalculated your access control list. So those are some of the things you need to be aware of. Okay. How do you feel about that? Yes, please.
Well, if you the problems of not every switch have those ACL yet, but my question is, have you seen in Europe the use of packet brokers?
Yeah. I'm going to come on to packet brokers in a second.
That's a better solution for security.
Yeah, but if you're feeding the packet broker with a monitor session, a span session, you still have the same issues. Yeah. If you're feeding it with taps, that's different. But if you're feeding your packet broker with spanned data, you've got the same issues as I've just described. Yeah. We'll talk about packet brokers in a second. Okay, so blade enclosures are the next one. Go into any modern data center and you see racks and racks of these things. So that's the front of the blade enclosure. Basically, one server per blade, 16 blades in this chassis. I think this is a Hewlett-Packard C7000 enclosure. but they all look pretty much the same. Lots of flashing lights, you know, the sort of thing. And on the back, what we have are two Cisco switches plugged onto the mezzanine, I think it's called the mezzanine card, you know, the intermediate bus between the blade servers on the front and the communications on the back. So how do we actually cope with these types of issues? How do we cope with capturing in these types of environments? So imagine that we've got a number of servers running on individual blades inside a chassis. The application server here is talking to the database server, and we want to capture. Well, actually, we can plug our capture unit onto a spare port on the enclosure switch, and we can set up a capture session, a monitor session, just like we would with any other switch. And with a Cisco switch on the back of a blade server, the commands are all the same because it's iOS or it's Nexus. So you're just looking at the same technology, just packaged up differently. Now, here's the trouble. Whenever you go to one of these blade enclosures, what you find is the switch on the back is totally populated with every port is in use, and people are desperate for more ports into the switch. I'm not quite sure why, but that tends to be how it is. And so the issue you may face is you don't have any spare ports to use for the monitor session. So in that case, what you can do is actually run the monitor session on a blade in the enclosure, and then set up a monitor session between your source and destination in that way. That's a way of overcoming that issue. Of course, the other way you could do it is simply run Wireshark on the database server, for example, which we looked at earlier. Advantages of capturing within the blade enclosure: it's pretty easy to configure, low risk, yeah. Multiple sources into one destination is possible, except for the overloading of the destination port, which we've spoken about. You can do VLANs just like you can with any other switch. And by the way, even if you don't have Cisco modules on the back of these enclosures, so for example, on an HP enclosure, you can use an HP Flex switch. They also have the capability as well. So you can get it with other types of blade switches. Again, I've never seen any proof of impact on switch performance, so that doesn't seem to be a consideration here. But some things that are considerations: you can overload the monitor destination, limited number of monitor sessions, you've got to have a spare port. That seems to be the biggie. That's the one that we always seem to have a problem with. And again, you know, make sure you check out exactly what you can do, what you can't do, and how you do it. A slight variation on that is Cisco UCS Fab Interconnect. So this is UCS system is a data center in a box sort of concept. Servers, network switches, storage, all in one rack, all monitored through this sort of all-in-one consistent management interface. Sounds extremely dangerous, but it's very popular. And within this, within the UCS environment, there are these things called Fabric Interconnect switches. When we first came across these, it seemed as though it wasn't possible to capture. Well, actually, it is. There is the capability. You can set up monitor sessions through the management interface for the UCS environment. This slide. My colleague created this. It's just showing fiber channel over Ethernet being captured, but there's a limit of 1 gig, an imposed limit. So you can, anything beyond 1 gig, you'll start losing packets. So that's perhaps not very useful for fiber channel over Ethernet. But you can also do it for server traffic. So server to server traffic within the UCS environment, you can set up captures. Yeah.
We are migrating from the HPC 7000s to Cisco UCS, and what we discovered is those Fabric Interconnect switches are actually based on Cisco's
Nexus 5000 chassis.
Okay.
And all those warnings about backing up data with the monitor port, we found to be true in the UCS environment. We actually took down 3 different blade chassis because we set up some mirror sessions on VLANs and backed up the monitor port.
Wow. Thanks. That's really useful. Okay. So there you have it. That's a warning.
Server guys are not used.
Yeah, I bet. I think on some, I don't know whether it's true on different types of fabric interconnect. It's certainly true between the 5000 and the 5500 Nexus switch. On the 5000, there was no default rate limit imposed. On the 5500, I believe it defaults to a rate limit of 1 gig. And I think that's also true on some of the fabric interconnects. That's why my colleague put here limited to 1 gig. But that's great. That's the sort of that's useful information. Okay, so pretty quick and easy to configure. See east-west traffic, and what I mean there is you see stuff between the blades in the UCS environment. We can, in theory, monitor multiple sources. We can monitor VLANs. We can capture storage traffic if it's fiber channel over Ethernet. Downside is we can only capture at 1 gig. The monitor and source have to be on the same fabric interconnect, and we're limited to 2 sessions. Anything else on that one? Okay. So the tap. Judging by the number of tap manufacturers who were here over the last couple of days, this is a popular solution. Okay, so 2 basic configurations of tap. There's endless configurations of tap, but I'll tell you about 2 basics. On the left-hand side, we have a non-aggregating tap. We talked about the fact that we've got 1 gig, say, full duplex server into the switch, and that gets fed out of 2 monitor interfaces out of the tap. So we can capture at the full 2 gigabits per second load. So that's one possibility. Of course, that does mean you need more ports on your capture unit. And then we've got the aggregating one where we're basically taking the transmit and the receive flows and we're pushing those out of 1 interface. So we've got all the same issues around overload, queuing, dropping, all those types of things. I don't know if any of you have ever watched LMTV. And Tim O'Neill on there, he rants about taps and things. He's a real evangelist for the use of taps. And he and I blog on Love My Tool, and I wrote a case for spans because he was going on about the fact that you should definitely give up with spans and you need to switch to taps. But of course, the trouble is that to get these things in place, I've got to break into the service. And that's the downside. So I agree, taps are great. And I've heard people talk about, yeah, well, you just need more taps. Yeah, but I've got customers that have got, 600 servers. Are you really, and they're probably all dual attached. So are we really going to have 600 times 2 taps, in place just in case? There's still a place for both, but taps are very attractive, I must admit. It's a great way to go. Back in the day, I used to run a wide area network, and I had this big patch panel, and there was nothing better than being able to take my massive autoscope protocol analyzer and just plug it into a circuit, like a transatlantic satellite circuit, and see the traffic straight away without having to ask anybody, set up changes, So I love this technology. I think it's great, but there are some practical downsides. So advantages, unlikely to get drop packets, but in aggregating taps you could. You get everything, including physical errors.
So in aggregating taps, if the packets are dropped, you see that they're dropped, or you don't?
No, you wouldn't know.
The tap doesn't.
No. They're totally passive. I guess that's probably stretching the truth of the word passive a little, but what I mean by that is they don't actually cause any service impact, certainly when they're working correctly. And the taps are engineered such that if they fail, they tend to fail in a pass-through mode. So you shouldn't have a problem, even if they fail. They nearly always come with dual power supplies as well. Obviously, you're not running anything on the thing that you're trying to monitor, so there's no impact on performance. But some of the considerations are you need to break in to install it, and they cost money, is one thing. Sorry? Require downtime to, yeah, absolutely, to install them. So that, in all, that may make them less flexible. And with non-aggregating taps, we need two capture points, two capture ports on our capture unit.
Two separate computer with two separate Wireshark, and then merge the two.
You can do that, or now, of course, you can, yeah, you can trace two interfaces at the same time on Wireshark, can't you? You can now. You didn't used to be able to, but you can now. You can capture from two interfaces, two network interfaces, into one file with Wireshark or DumpCap.
So just one section of Wireshark and you can
Yeah. Yeah, because since one of the releases, and I don't know which one it was, they introduced the ability to be able to capture from multiple interfaces concurrently. So that gets you over that problem. Whenever you do this type of thing, you may get some out of order issues where packets get slightly out of order, and it's to do with the way the interrupts are serviced on the network cards. So just be aware that you may get some stuff that appears to be out of order. But it'll be obvious, because what you'll see is you'll see things like an acknowledgement for a frame that you haven't even seen yet, you know, that it's further down the trace. But it's usually only when you get up to really high speeds and low latency and, you know, things where the frame gaps are very small, then you may get some out of order issues. Aggregators suffer the 2 into 1 issue. You know, 2 gig into 1. So packet brokers. What you can do with a packet broker is you can feed it with different sources. So taps, spans, in theory other sources, although I can't think what the other sources are for the moment. But anyway, we can feed packets into the packet broker. It can then feed that data out, aggregate it and feed it out to the capture unit. You can apply filters within the packet broker. You can slice the frames. The packet broker will generate timestamps for you, which are more accurate than the capture unit. You can dedupe packets as they pass through the packet broker. And you can do many-to-many. So you could have multiple capture units, multiple sources. You can link it all up any way you want. So quite attractive, but, you know, more hardware to deal with. Doesn't overcome some of the limitations of span and tap, but it's tremendously flexible. And certainly if you have a lights out type data center, or you're using a third-party data center where it takes you a week just to get through the front door, then having this capability is very attractive, being able to configure things up as you need it. Of course, the products we're looking at are Gigamon, they were here, and Ixia can use an Arista switch as a packet broker. And Arista have put quite a lot of documentation on their website about using their switch as a packet broker. It's reckoned to be a low-cost alternative. I don't know anything about the pricing, but that's one of the attractions. Any questions on that lot? Okay, virtualization. Who had this idea? So we've got one physical host, we've got multiple virtual machines running within it, and we've got a vSwitch, virtual switch. Traffic's flowing between an application server and a database server. We'd love to see that traffic. So how do we get it? Well, one of the things we can do in a VMware ESX environment is we can set the switch, or certainly a group of ports, into what's called promiscuous mode. So it just means that we can drop ports into this promiscuous mode group, and you'll start to see the visibility of the traffic that's flowing within that group. And so that enables us to actually capture traffic to another VM that's running dump cap, let's say. VMware have a marketplace where you can download pre-built virtual machines. I think there's an analyzer package that you can download, so you don't even have to build the virtual machine yourself. But anyway, we can do it with dump cap and the Linux VM or a Windows VM.
So with that promiscuous mode, does that mean in that case the app server would be getting all the packets to the DB server as well?
I believe not, no. I think, do you know, I'm not sure. That's worth checking. I'm not sure. I don't think so. My understanding is it sort of converts this group to operate like a hub, like an Ethernet hub. Yeah. So to monitor our virtual analyzer out here in the outside world, we'll need a PC, and we can connect to the virtual analyzer using Windows terminal services. So MSTSC is the command on Windows, or you can use the vSphere client to drive the console of the VM that's actually doing the capture. So that's some of the practicalities. Advantages of promiscuous mode: you can pretty much do it as and when needed. You can capture, depending on the configuration, you can capture any east-west traffic, any stuff going within the switch. The downsides are you need a VM. You need to take care regarding where you're going to route the traffic to, just like in all the other methods we've looked at. And there has been this anecdote, and I heard this statement made by someone from Ixia: oh, it creates tremendous load on your server, on your ESX host. That has not been our experience. We have not had anybody tell us that they've detected a tremendous increase in load. I don't know. So we don't seem to have any pushback in configuring this, and we don't seem to register any increase in load. Obviously, most ESX servers are quite big, sort of 16-way or something, quite big units anyway. So, and it's only going to make one of the CPUs busy because it will be single threading for that particular task. So I don't think it's an issue. But one thing you could do is run it for a short period of time and monitor CPU load and see what happens. You may be aware that in an ESX environment, a virtual machine can be migrated from one ESX host to another, seamlessly migrated using technology such as the way it detects it is a technology called DRS, I think, and you call it vMotioning, moving the virtual machine. The trouble is, if you move the virtual machine, then your capture unit's now capturing on the wrong host. To get around that, what you can often do is you can ask the VMware support people to pin the virtual machines into the host. So they can set an option, I think it's called affinity, where they pin these two and make sure they don't get vMotioned. So that's something you can ask them to do while you're doing the capture. vMotioning is done for load balancing purposes and also for failover. Hyper-V technology has the same capability. It's called vMonitor ports. Same type of setup, same sorts of considerations in terms of the advantages and the considerations when you're actually doing the captures. A commercial alternative to all of this is, for example, there may be others, this is just one I happen to know about. There's a product called Phantom vTap from Ixia. It's a driver that is installed in the ESX kernel, and it can capture traffic flowing within the vSwitch. It outputs it through a GRE tunnel, and then you have some unit out here as a terminator. They propose one of their Ixia external boxes that I can't remember the name of, but I believe you can terminate it with other GRE terminators, switches and routers, and then you can feed that into your capture unit. This is supposedly much lower overhead in terms of load, but aside from the fact that I haven't found load to be an issue. You don't need any additional software on the VMs. no impact on performance. You can capture all the vSwitch activity, or you can capture specific traffic. Works on ESX, Hyper-V, and Zen server. So the main virtualization hypervisors. And it will track things through ESX vMotion because it has a management machine that keeps track of things. Considerations: you have to run this management VM on each host where you're using vTap. Probably not a big issue, quite honestly. And you've got to pay an annual subscription for the vTap. And it's sensitive to the performance of the management VM, so you just need to make sure that that is set up with adequate resources. Otherwise, you can get problems with capture. So we've covered a lot. Here's some places where you can get more information. Obviously, there's a LinkedIn community started by Mike Panacki called Protocol Analysis and Troubleshooting. There's a lot of stuff and banter that goes on there, with some quite useful stuff. I have to promote my friends at Love My Tool. Make sure you're aware of that. We have some blogs on there and occasional interviews and things where we're covering this type of issue. And then there is this website called TribeLab. Advanced 7 offers commercial troubleshooting services, but we are very keen to promote evidence-based troubleshooting to the entire community. And so we're sharing a lot of our knowledge and our experience and techniques and even some tools actually through the TribeLab site. So I'd encourage you to go there, join. You can get a lot of information there. We're trying to build it up as we go. It's not going as quickly as I'd like, but hopefully we'll get more and more information on there. And I think you might find that useful. And of course, you can contact me. So that's the end of my presentation.
Oh, can we go back to this slide at the end?
This one or
Yeah.
that one?
Wouldn't it be like more, elegant solution to just remote pickup, and manual servers and just, capture traffic remotely as a remote interface, and you don't have the issue just VM, remote pickup on the office VM, and off you go, right?
Yeah. Are you saying there is that capability or there should be that capability?
No, there is such a capability. If you go to Win pickup, I guess, like there is a remote pickup, what's happening that you do, when you open Wireshark, when you just manage interface, there's a tab, remote interface, it assumes that this service is running, and the service is looking for the boom.
Oh, I'm with you. I see what you mean. So you could run, you could run it as a daemon. Yeah, you could do. I think in this case, that's a good argument against the promiscuous mode thing and all that stuff. But in this case, the reason that I think this is being done this way is because you can imagine that if you replace this with a packet broker, then you can start to feed virtual traffic and real traffic all through a packet broker and manage it and feed it out to any device you want. Yes, please. Could we?
Could we use a
A
hub?
hub.
Does it still available?
In theory, you could use a hub, say, between a PC and a switch. And I've read lots of people say that they do it quite frequently.
With more than one, from multiple PC, we would get collisions, and that would slow down the network.
Yeah, no, you wouldn't do it that way. But say that you're in an office and you've got a PC and you want to see the traffic from the PC into the network, you could cable it through a hub. I personally wouldn't do it, but I have heard of people who do it.
Because it's much easier to use that.
I'd rather use a tap if I had to, or some other way of doing it. I don't like the idea of connecting a hub in there in case I cause some sort of problem. I don't know. There isn't really a problem, I guess. There shouldn't be a problem. Yeah, of course. It's going to limit your rate to probably about a third.
What you're looking at.
Yeah, that's the trouble, isn't it? It does affect what you're looking at. That's the point. So whereas if you used a switch between the PC and the main switch, you could perhaps capture the full 1 gig Actually, it's more likely to be 100 meg if you're going to be able to put a hub in, I guess. But you can capture 100 meg full duplex, no trouble. If you put a hub in there, then you're probably coming down to 30 megabits per second before you start to see collisions happening on the hub and things like that. So maybe not with a single device. I don't know, it's too risky for me. I wouldn't go that route. Anything else?
What are you doing in like the data center for like your class architectures, where if you have to have something in place capturing all the time, you know, and you're running thousands of switches, you know, massively scalable. You just span off of the spines, or you do 40 gig taps off the spines, or, I mean, that's the reality.
Okay. We do use, we're coming in as an outside organization, and some of our customers have like a large estate of InfiniStreams or something that are capturing, and we will consume the data from the InfiniStreams. I don't think there's an easy answer for what you're saying, because aside from the fact that you need the hardware and everything to be able to feed the data into the capture unit, of course, even the best capture units are only going to capture at something like 7 gig. You know, and there's some SSD capture units coming out now, but of course they lack the volume. And I actually presented at Interop London last week, and I attended another session, and there was a guy there, and he was saying that the US government were trying to insist that they capture every single packet through his environment, and he said, how am I going to do that? You know, we just don't have the technology. And I think, you know, you're going to face the same issue to some extent. We don't have the technology. We barely have the technology to cope with 10 gig, so 40 and 100 is going to be a real challenge. I'm sure it will come down the line, but, you know. We sort of have gone through this period, the 1 gig period, and it's been a sort of utopia, really, because you can usually create a capture unit that will quite happily capture at 1 gig. And the 10 gig has just gone a bit too far, and then 40 and 100, now we're really pushing it, and so capture is going to be more challenging. Yes, please.
Talking about latency, from your experience, do you feel that is there any drop packet that you capture?
I'm sure, yeah, we do drop. I'm sure we drop packets in a 10 G capture, yeah. But the thing is, that's why if you.
That's roughly 5%.
Well, it depends what you're capturing to, doesn't it? If you're capturing on a laptop, you're going to lose loads. If you're capturing on the server that I talked about before, my colleagues think you can capture somewhere between 1 and 2 gigabits per second in the configuration we run them.
You have the best solution in place.
You have the best solution in place.
Riverbed.
Riverbed, yeah, okay. So,
Those you charge.
yeah. So NetShark will go at 7 gig, won't it?
Yeah.
But obviously you're still going to lose some if you go above 7 gig, which is, you know, these are some of the issues. We're going back, when I first started to troubleshoot problems, we used to capture into memory. But of course that was a challenge because it used to wrap so quickly. So then you get into the stage where you have to start to filter while you're capturing. So you only capture what you really need. So we're going back into that sort of phase, I think.
But what we do just partial. Just capture the behavior.
Yeah. Yep. The trouble is we always end up slicing the bit that we need. Yeah, you don't get the bit you want to see. I think we should let you go because you've got 10 minutes to go to the next presentation. So, thank you.